All right, so we're gonna prove vandermonde's identity. So again, let's look at the right hand side and the left hand side. So this is the right hand side, left hand side. And so in the right hand side, let's treat this as committees, right? So you're basically choosing an R-membered committee. Say committee. Actually, we have m plus n. Okay, say we have a m plus n sized committee, and the right hand side is telling us that we are choosing our people from that committee to form a subcommittee of k people. And we want to show how this is the same thing as the left hand side. So what is the left hand side doing? So normally I like to take a look at inside the summand and then look at the summation. And so inside the summand we have m choose k. We're choosing k. We're having m like a committee of m size m. We're choosing a subcommittee of k. I'm sorry, this one's not. It's R people, and then we have k people in this subcommittee that we chose from this committee of m people, and then we have another committee of n people from here. Let me that one. Let me that. And we're choosing r minus k members of a subgroup. And so how are these here the same? So let's interpret the left hand side as choosing m men and n women committees. So these can become subcommittees of this committee. Why? Because well obviously m plus n is going to be greater or equal to m or n individually. So we could choose m people from the original committee. And so if we choose so we're basically saying that we're splitting this into men and women. Two committees and then women with men and women. And then so that's gonna be equal. And so basically from the men, we're choosing K people to form a subcommittee. And then another subcommittee from the woman to form R minus K people. But notice that K plus R minus K is equal to R. And so this is the same thing as choosing R people to form a subcommittee, but just choosing men and women separately. So why do we need a summand? Aren't they just equal to each other? Well, we actually need to account for all possible cases, right? Because this is just representing like one instance if we just have a k equals to 0. And so we need to account for all the possible cases to represent all the possible scenarios that we can create some we can choose some R people from n plus n. And so what is the range of k? Well, it's clearly you can have k men. You can choose k men and uh and you have R minus k woman. And so for men, we're trying to find the range of k. K can range from 0 to R. Why? Because the least number of men that you can have is 0, and everyone that you choose is a woman. And the most that you can have is all of your selection, all of your R selection of people as men. So you can have k men, and then you can have everything in return. And yeah, that proves the double count. That proves the Vandermonde's using double count. That's it.